Introduction to NumPy and Arrays. In this first module, I'm going to give you an introduction to NumPy and arrays, followed by the attributes of a NumPy array. To install NumPy, we use pip, which means Preferred Installer Program. It is a Python package that helps us to install different Python packages or Python libraries like NumPy, pandas, matplotlib, and the rest. This is the command we use to install NumPy. The reason why we have a bang here is because we are running this command in a Jupyter notebook. If we are running this command in our terminal, for example, like our command line, we just need to type pip install NumPy. After installing NumPy, we then import NumPy. We can import NumPy just using this line of code. However, it means that every time we need to use the library, we have to type NumPy. So we add this in order to create an alias for it. So every time we need to use NumPy, we just need to use np and we'll be fine. How do we create a NumPy array? It's very simple. Start with declaring a variable and then followed by the np.array function. With the array function, we pass into the argument of that array function our list of value. The list of value can be one-dimensional, like we are seeing here, or it can be two-dimensional, as we would see during the course of the course. As we see here, we have created a NumPy array. To verify that, we can use the type function, which is an inbuilt Python function, to check the type of a particular variable. As we see here, is now a NumPy array. There are 7 major attributes of NumPy array, but for the simplicity of this course, the 4 major ones have been highlighted. The ending returns the number of dimensions of the array. As I mentioned, this particular array that we created earlier is basically a one-dimensional array. The size returns the number of elements in the array. Here we have 5 elements, so this property will return 5. The D type returns the data type of the elements in the array. For an array, we would expect that the data type are the same, because the reason why NumPy exists is to help us computationally run different mathematical operations in a faster way. With list, we can achieve some things that we do with array. However, NumPy array is actually faster when we use it for our mathematical operations. For the shape, it returns the size of the array in each dimension. Here, we can expect the shape to still be 5 because we have just one dimension for this particular example. Let's see how we can put this attribute or how we can get this attribute using NumPy functions. As mentioned earlier, we import NumPy as np, creating an alias for it. In the first line of code, I have created a NumPy array with different data types. Remember that I mentioned that when we are creating our arrays, they are not created or they do not function to work with different types of data types. So this is a wrong way to actually create an array. Most of the time, the data types of the array should always be the same. So even if I want to declare a number 1, I should be making it 1.0 if I want to make it all float values, or I'll round up these values to the nearest integer. But in this case, to maintain the float data types, I can just add 4.0 and make this also 5.0. This way, everything is the same data type. For the shape of the array, after we've declared an array, we get the shape by using the .shape function. And to get the number of dimensions, which returns the number of the dimension of the array, we use the function r.ndim, just like we've seen here. We just need to use that function on the variable, which is the array that we have created earlier on here. Actually, in this case, I've recreated it with another variable.
Hello there. If you have enjoyed this course so far, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing. I do hope you have. Let's carry on with the course.
For the data type, we use the .dtype function to get that value. And the data type return the data type of the element in the array. Like I mentioned, this works because array are supposed to have the same data type no matter the amount of elements in that array. And to return the number of elements per the dimension, we use the array.size. So let's look at what this has given us. For the shape of the array, as we see here, it returns 5 because the shape of this array is 5 based on the fact that it is just one dimensional. We will see the shape when it comes to multi-dimensional. For the data type, we can see that the data type is float 64 because we have float numbers here. If we decide to change everything to 2, 3, 4, 5, we will see that that changes it to int64 because they are all integers. For the size, which returns the number of elements, we can see that we also have 5. And it's the same as the shape. This is because it is a one-dimensional array. Let's see the same attribute for two-dimensional array. How to declare a two-dimensional array is also very straightforward. We only need to create one first array like this, and then we insert our two arrays inside that array. This makes it multidimensional. In this case, we call this two-dimensional. Let's print the attributes. As you would see here, the shape is a 2 by 3 because we have two different arrays, or can call it list, and then, but let's maintain the word array. We have two different arrays and each of them have 3 different elements. So it is a 2 rows by 3 columns array, and that's why the shape is 2 by 3. For the data type, they are all integers, so we have integer. For the size, we can see the size returns the number of elements in the array, and of course we have 6 numbers inside this array. And lastly, the number of dimension is definitely 2 because we have 2 arrays inside of here. Now you may be wondering, what is the major difference between, you could create this as a list, right, without actually making it an array, and I'm just going to show that right away. However, if we look at the type, the type is a list because it has not been passed into the np.array function. What is the major difference between a list and an array? These lines of code will show us exactly that. I'm not going to be explaining this code, but what I've basically done in this code is to create a list and an array. And then I'm doing some aggregate functions like the sum of the elements in the list, the sum of the elements in the array, and I'm checking the time that it has taken to do the sum. This will prove to us why NumPy is very brilliant. As you may have seen, the time that it has taken for the NumPy array is definitely faster for the same computation, the same numbers for the Python list. And this is where NumPy actually shines because it helps us to compute things even faster. This may look like a very non-significant difference between the seconds that it has taken, but when we are dealing with a large chunk of numbers, NumPy will be much more effective. Here, I am showing you the D type of an array of floats, and it's because I want to mix the data type to show you what it looks like. So first of all, let's look at this. It returns a float, So let's change one of the value to integer. You can see that even though there's an integer there, it just takes precedence over the float. This is not because the number of the floats are actually more. If we decide to make just one of the value floats, the float will still take precedence. Can you see? So this is why it can be very dangerous to mix different data types in our NumPy array. They are created to have just one data type. Next, we will look at array indexing and slicing.
Hello there. If you have enjoyed this course so far, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing. I do hope you have. Let's carry on with the course.